Now that covers the procedure for plotting frequencies on the chart. Frequencies occur when we observe the behavior, we count it and time it, and we divide the count by the time and we get a frequency. But other things can happen on days, and one of the things you notice if you thought about it is that there are 140 days there. We should do something about each one. We can't just pull the calendar apart and throw away the days that we don't use. So what are we going to do? What are we going to do in case that the behavior happened, but for some reason or other nobody recorded it? Or they recorded it but lost the data. So it happened, but we can't see it on the chart, which means we're ignoring it. How do we deal with ignored days? The rule is, as you can see in the example, we draw a line connecting the two closest recorded days. And so where the line goes through the ignored day, that's probably our best estimate of the frequency for that day. Now it might have been, had we recorded it, we would have gotten a different frequency, but since we didn't, we have to use the data we have to make an estimate. But by drawing that line there, we're telling the viewer that the behavior was in fact ignored. So that's two things that can happen on a given day. Either we can observe the behavior, count and time it, get a frequency and record it, or we can ignore it. We can let it go by. Now there is a third possibility, and these are the three. This is exhaustive. The third possibility is that the behavior has no chance to occur, and therefore cannot be recorded. If, for example, we are keeping charts of children's performance in school, by definition, unless it's a very strange school, they're not there on Saturday and Sunday. So Saturday and Sunday are no chance days. How do we deal with no chance days on the chart? We leave them blank. So now we have all three procedures for handling the three things that can happen on a given day with regard to behavior. Number one, it can be recorded. We count and time it and drop a frequency dot. Number two, it is ignored, and so we just draw a line through that day, connecting the closest recorded days. And the third thing that can happen is there's no chance. Now you can see, looking at panel D in the figure, examples of all of these things going on at the same time. Very often, as we're charting behavior, we decide to make changes of some form in the environment in which the behavior is occurring. We may change curriculum, for example, in a child whose reading behavior we're charting. We may add some kind of rewards to try to improve the behavior of our 2-year-old who is very slow to comply with our requests. These sorts of things we call phase changes. We're changing the phase. We're making a change in the environment that the individual is behaving in. And so we want to indicate those on the chart. And we do that by drawing a line between the recorded days separating the before and after the phase change event. In other words, if we have going to change the phase, change the procedure, starting Tuesday, we will plot Monday's data, and instead of drawing a line to Tuesday, we'll draw a vertical line between the Monday and Tuesday line and identify that line with whatever the phase change was, like new curriculum. And you can see examples of this in the figure. On that one you see that we've got, for example, no chance days, but we then make a book change between the Sunday and Monday of the 6th week, and that would constitute a phase change. And that's illustrated clearly here. Finally, in order to make it easier to view the records, it turns out, it's been found that it makes it easier for us to see what we're doing if we connect the dots when we can, instead of just leaving blanks between the adjacent recorded days. So in other words, you'll see as we look at the examples that the dots are connected unless there's a no chance day intervening. In that case, we leave it blank. But we connect even adjacent, non-adjacent recorded days if, as we said, that day happens to be ignored. So you'll see lots of patterns here of dots that are connected. And that makes it easier for the eye to follow the trend, which is, of course, one of the reasons we do this charting in the first place. If you see a dot on the chart at 5 movements per minute, can you tell what the count is? Can you tell what the time was? The answer is no. because the count and time have dissolved into the creation of the frequency. It turns out that it's very useful for us to not only see what the frequency was, but to see what the time was involved in recording that produced that frequency. So we have a convention for showing that on the chart, and we refer to that as the counting time floor or record floor. Now think of the word floor as being the lowest value that you can see, lowest frequency you can see, given the amount of time you spend recording. For example, if you only record for 1 minute, you cannot see frequencies less than 1 per minute. If you only record for 10 minutes, you cannot see frequencies less than 1 in 10 minutes, or 0.1. Now, the frequency may be there, but you can't see it. In the same sense that if you have a thermometer that only goes down to 30 below zero, and you hang it outside your shack in Alaska on a cold winter night, and in fact, the temperature went down to 48 below zero, you'll never know that. All you'll know is it went below 30. In other words, your thermometer sets a floor at 30 below zero. Any charting procedure in which the time is predetermined and limited sets a floor on frequencies you can see. And we call that the counting time floor or the record floor. And we denote it by a little dashed line, as you can see in the figure, corresponding to the reciprocal of the number of minutes we spent recording. Now, what does that mean? That means simply 1 over the number of minutes. If it's 1 over 3, that reciprocal will be 0.33, and you plot that on the chart as a little dashed line at 0.33. If the recording time was 10 minutes, the reciprocal is 1 over 10, or 0.1, and you put a little dashed line at that value. And you can see several examples on the figure. Now, there is another kind of floor that some people like to use, and we call that the behavior floor. Now, the counting time floor, the record floor we just described, is limited by the number of minutes we spent recording. The behavior floor is limited by the number of minutes that the behavior can occur. For example, the typical school day is 6 hours long. So the behavior floor would be 1 over 360. The record floor might be 1 over 60. If you spend an hour recording in reading class, and you're recording class, for example, talkouts, and you record for the whole hour, your recording floor or record floor or counting time floor, whichever term you want to use, would be 1 over 60. But that behavior could continue to occur throughout the 360 minutes or the other 300 minutes that you did not record, and so you have a little area in there limited by the behavior floor at the bottom and the counting time floor just above it. And that little area consists of ignored minutes. Ignored minutes. In other words, that's minutes the behavior could have occurred, but you didn't record it. So that's ignored time. Now, the minutes below the behavior floor, that is from the 1 over 360 line all the way to the bottom of the chart, those are no chance minutes. The kid cannot talk out in school if he's not in school. So for the hours of the day that the child is not in school, those are in fact defined no chance minutes. So therefore, you have now the whole story. You have the minutes spent recording, you have the minutes that you could have recorded but didn't for whatever reason, and you have the minutes that you could not record because the behavior could not happen. Now, you recall that earlier we mentioned that Skinner thought good behavioral records were complete, and this is complete. You see, we have now told the whole story about the recording procedure. The recorded days, the ignored days, and the no chance days. And turning it over into time, we've looked at the recording time, the time we could have recorded but didn't, where we define the behavior floor, and finally the no chance minutes, which are below the behavior floor. So the two floors and the conventions on ignored and no chance and recorded days enable us to tell the viewer of the chart everything that person needs to know about how much recording we actually did with respect to or as a proportion of the recording we actually could have done. and that's a way of saying that the record is complete, or if it's not complete, what the sampling was that we engaged in. Now there's another kind of limit on behavior frequencies on this chart, and that's called the recording ceiling. Recording ceilings are imposed by recording practices or recording procedures that set arbitrary limits on the frequencies that we can observe. For example, if we have a recording procedure in which we look to see if the behavior occurs every 30 seconds, in other words, every 30 seconds, as a 30-second interval goes by, we look and see, did it happen? And then the next 30-second interval goes by, did it happen in that one? Okay? So the most counts we could get with that procedure would be 1 every 30 seconds or 2 per minute. Therefore, the recording ceiling that's imposed is 2 per minute. Can't see behavior above 2 per minute if you're only looking for it once every 30 seconds. Now, clearly, we do not recommend that practice because we would like to be able to see frequencies above 2 per minute if we possibly can, particularly if it's a high-frequency behavior that we want to decrease. Now, if you like metaphors, you can combine the words floor and ceiling, and you get a kind of an image of a window. Right? I mean, the floor and the ceiling are the limits where you can put a window. From the point of view of observing behavior, we want our window to be as wide as possible. What does that mean? We do not restrict it at the top by putting artificial limits on the frequencies that we can see, and we try to lower the floor as much as possible so that we can see low-frequency behaviors if, in fact, they're occurring. So the combination of the ceiling and the floor define for us a kind of a recording window which we can try to increase, make as large as possible, to make our recording procedure as sensitive as possible to frequencies over as wide a range as possible. Okay, let's turn now to another aspect of behavioral recording that many people find very useful, and that has to do with recording properties of just one behavior. Now, I want to proceed cautiously here because this could be confusing. What we're going to do looks like what we do when we create a floor, but we're going to do something slightly different. We're going to begin by asking the question, would it be useful to record the latency of one behavior? For example, would you like to know the latency between the time the alarm clock goes off and Tommy comes down for breakfast? Well, you can record that. If you record with a timer the minutes that elapse between the sound of the alarm clock and Tommy's appearance downstairs for breakfast, that would be a latency. How do we put that on the chart? Well, you'll notice that up the side of the chart is not minutes, it's count per minute, or frequency. Here we have a case in which we're dealing with a count of one behavior. Tommy came down to breakfast. The question is, how long did it take him? So we create what we call a latency measure. Not latency, but latency measure. And we create that the same way we would create a record floor. We take the reciprocal. We divide 1 by the latency. 1 by the number of minutes that it took Tommy to come down. So 1 over latency is what we call a latency measure. And we plot it on the chart exactly as we would a floor, except instead of making a little horizontal line, we make a little slash line like this, a forward slash. Now, I remember the forward slash because the word latency ends with Y, and if you look at where the tail on the Y is, it's like a forward slash. Okay, so that's how you record latency. And you can record latencies over several days. You can record latencies within a single day by stacking them up on that day line. And it turns out to be a very useful measure in some cases. Now, another property of single responses is how long they last. That's what we call duration. And we deal with duration the same way we deal with latency. We create a duration measure, which is 1 divided by the duration. For example, if I have another sneezing fit, it'll last like 7 seconds. What was my duration? 1 over 7 seconds. The duration was 7 seconds, the duration measure. What was my duration measure? That will be 1 over 7 seconds. If it takes me 35 minutes to do my commute to work, my duration measure is 1 over 35 minutes. And you plot that on the chart exactly as you would a latency or a record floor, except that we now turn the slash the other way and make it a backslash. So you can look at a chart and you can see backslashes going along and you can see latency measures going along. Now, why do we turn them over? Well, there's two reasons. One is that the chart doesn't accommodate time up the side. It accommodates count and time or frequency. So we have to convert the latency measure to a frequency. Secondly, if you look and think about it, you'll see that as the latency gets shorter, the frequency gets higher. In other words, if I go from 1 in 5 minutes to 1 in 1 minute, what's happened? I'm going faster. So the frequency is increasing. By the same token, if my duration decreases, my frequency will go up. If, for example, I am measuring the time I spend between sitting down to study and getting up and leaving, and I plot the duration measure, we will see that as that duration gets shorter, my duration measure will get larger or go higher, as it should. Behavior can happen more often if it's not taking too long to happen each time. So as the duration gets shorter, the frequency goes up. As the latency gets shorter, the frequency goes up. Okay? So these are the procedures we have for displaying latency and duration on the chart. And again, many people find these particularly useful in some situations, particularly various therapeutic situations. We have now put in place some of the procedures necessary to produce a simplified method of charting. Frequency is count over time. Now, we're going to look at the algebra of this for just a moment and call attention to the fact that count over time can be written as count multiplied by 1 over time, right? As frequency is count divided by time, which is also can be written as count multiplied by 1 over time, or the reciprocal of time. But what's that? That's the record floor. So if we have located the record floor on the chart, all we need to do now to find the frequency is multiply, go up the chart, by the amount that the count is, and put the dot where it goes. So in other words, if we have located the record floor, we move up by the amount of the count from that floor, and as we get to that point, we have located the frequency. We have multiplied, in other words, 1 over time by count. Okay?